Hello everyone, so welcome back. This is part 2 of the math series of the machine learning course and the third video in the machine learning playlist as well. So thanks for your support in the part 1. I see a lot of you viewers watching that video. Uh, Now moving towards the second part, what the other topics we will be covering in that are discrete mathematics, stats and probability distributions as well and like some related to logic aspects as well, like where we are using these topics and how we are using these topics in advanced machine learning concepts as well. So we will be covering up, wrapping up with the maths part, and from the next on, we can focus on with the basics of Python as well, and we'll move forward in the machine learning like playlist as well. So let's get started. Okay, so based on the bootcamp, we have covered like linear algebra and calculus as well. So if anyone has any doubts in these topics, you can ask me, message me on, comment on YouTube as well, and like you can personally ask me on LinkedIn as well. So these are some topics like metrics you must be familiar of, and the calculus. You should know like most of the things which I've told, like those are important as well. Based on the later parts of the topic where we will be deep diving into most of the algorithms, how they are framed, how they are actually being used as well. So you should be you should have clear understanding of these topics moving forward. Now coming towards the discrete mathematics. Discrete mathematics, I see like they have given a YouTube channel by Dr. Trevor Bezek. It's a really good channel. Like if you want to learn complete discrete mathematics, but there are a lot of videos. Okay, so we don't require that much amount of discrete mathematics in machine learning concepts as well. It's nice if you do them all, but if you want to focus precisely on like machine learning roadmap and type, I've curated the important topics out, and these are like such important topics. What are those? Set operations. Like basically starting with discrete, you should be familiar with the set topics. What is union? What is disjoint, set difference as well, intersection, and all those topics like complement and Venn diagrams also. So these are some of the most easiest of questions we used to say in our engineering and like in school as well. So yeah, these are really helpful in defining the logics as well. While moving forward, we'll do a like short cover up if required. So just a quick go through of all the set topics. What is A union B? This is basically everything of A plus everything of B. And what is A intersection? How do we draw that intersection? Like let's say, okay, we also use something called AND. So how to, what are the intersection? It's what we have common in AB. A dot B, that is also used to write in logic as well. A minus B elements in A, this is basically what we used to say set difference. So that's just basically, that's just the same, that's A minus B. Elements which are in A, like all the elements in A that are not in B. So by Venn diagram, like, okay, that will be more easy if I just draw Venn diagram. Yeah, that should be good enough. So that's your set A, that's A complement everything except A. That's and we are destroying sets. Okay, like those are not overlapping. These are a proper subset of A. All of it is inside. This is intersection. This is A intersect B. This is A union B. This is A minus B only in A complement. So these are some of the basic concepts of set. Now moving forward, what we have is cardinality. Cardinality is just related to numerical concept in the sets. Like cardinality of a set is the number of elements inside that space as well. There are some formulas for that, like proper subset and so on. So it's just some easier things. Relation and function. Okay. Now that comes the something interesting. Like that might be a little bit confusing for those who are not aware of that. Relation and function. Discrete maths. Yeah. Okay. So let's say we have set A and set B. These are elements of set A. These are elements of set B. So basically, what is relation? Relation is between basically the connection between the two objects. That is the connection between set A to set B. It doesn't depend like how it is connected. Now coming back to function as well. So function basically you define like what is your data doing with that. Basically, it is a kind of like specific relation where you are clearly indicating that this element maps to this element, like or this element do these operations from the set called the domain is connected to exactly one unique element in the second set called the range. It's basically okay. That's something I forgot. There basically is a domain to range mapping, and there are some kind of functions like relation is every kind of mapping you can have, like one maps to two or three, but in function it is very specific. So there are some relations that are like one, uh, many as well. So let me just yeah, okay. These are the important types. And yeah, types of function you must be knowing like constant function f of x is equals to some constant c, identity function 1, polynomial like fx is equals to 2y plus 3, relational function trigonometric sin x, exponential 2 to the power x like something related to logarithmic like in the function of log, piecewise even and odd functions like they're based on their values, periodic functions like sine waves and so on. So coming to one, it's basically it is not an injective like one element of A maps to only one of B. Many one is basically one to many. Now bijective. Uh, okay, one is basically one element of A maps to only one element of B. But what is onto one element of A have map like no two elements of this. Okay, sorry. Onto function stands for no range in B get stays empty. Like if we have the three elements in the set B, all of them are being mapped by some of the elements from A. This is the onto function bijective, which is one and onto. And like moving on to the next topic, power sets and Cartesian products. These are basically the supersets of like your relations and functions. Power set is something a set comprising all the subsets of a particular element. Like if we have set A 1, 2, 3, that power set will be uh, is a set containing set of 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and null. Cartesian product is basically understand how like how many products you can form, how many relations you can form between those two sets and so on. Now that comes the logical part. Core discrete math and graph topics, graph theory. Okay. Uh, uh, the engineering students must have done graph. Let me just go through a basic understanding of that. Uh, sample graph. It is one of the most widely studied in DSA, and it's an easier topic as well. Sample graph. Okay, let's say, yeah, let's take this one. So this is a connected graph, undirected graph, no edges points to some other edges, and this is a connected graph. So what are these vertices? These are edges, And okay, what's something that I node vertices, edges, these are called nodes, and something is basically like visiting each edge is called the path or something articulation points. I don't familiar with the like specific keywords. Adjacency matrices, like how you're covering that graph. Graphs are critical method for recommendation agents. Yeah, all these are something which you have to do. So a graph which has all the nodes connected is a connected graph. It has if it has some disjoint, it is disconnected graph. It has a if a graph has some cycle, then it is cyclic. If it doesn't have, then it is acyclic graph. These are two components of a disjoint graph. And uh, what else can we say about graph? Okay, one more thing. Articulation and bridge point is something we can say. Yeah, okay. Let's say 2 here is the bridge of the graph, and articulation point is something. Let's say, yeah, this edge is the bridge of the graph, and 2 here is the articulation point. So basically, if you remove 2, we have two different components, and similarly, if you remove this edge, we have two different components. So that's something advanced I can think of. Rest all is just a similar theory of the graph we are required in ML. Why is graph useful? Because in neural networks, in analysis, in all the recommendations, we use graph to form our logics, like data moving from one end to other, how it's moving through the cycles and so on. So that's the section where the graph comes in handy. And yeah, combinatorics, permutation and combinations. Okay, yeah, that is counting is must. So you must be aware of like if these are all the possible form of combinations we can make. Okay, like the difference between permutation and combination is very simple. In permutation, you have, let me just clearly write permutation order does not matter. Order matters. I write that. Yes. So, and basically, what happens in permutation if you have five balls? So, here, if you are arranging them differently, for two, their order matters, but in combination, that order doesn't matter. So, if you are joining the two at, if you want two, so how many ways you can have two? So, here that does not matter, but in permutations, it matters. Like you can do it by a lot more way. And now, moving forward, what we have, logic and proof techniques. Yeah, Boolean algebra quantifiers, truth tables. Yeah, this is something like implies on and logic is something which is required, like modus ponens and modus tollens. For that section, you can refer to the video if you want that to be done in detail. Okay, so yeah, it's covering equivalence relation, intersection, set theory, truth, university conditions. Yeah, tautology, contradiction, truth table from like starting ones. So from ninth to let's say 14th and 15th. Yeah, 22 modus ponens and modus tollens. These are some of the rules like of the discrete mathematics. So how rule implies, let's study that as well. So like let's say if your statement A, statement B, statement C. let's say you have four statements. How machine will make the logic out of them? So there are certain rules like for modus ponens. So what does modus ponens say? If A is true and somehow you prove that A implies B as well true. Like these two are true, you know. So by modus ponens, you also implies that B is true. Like most of you will say that's common logic, common understanding, but it is common understanding for us. For machine, you have to feed the data, modus ponens. Like let's say here, if you go, okay, so if you have A implies A does not implies to B, and something you have negative of B, so that means A must be true. Like it stands like that. So there are a lot of things as well. So negative of A, there must be negative of B. Somehow that we can confirm it to modus tolerance MOTUS. That promise one modus tolerance if P then Q not Q therefore not P. Okay, yeah, that not must be here. Like that's just the opposite of like modus ponens. So these are certain logics which you will require while moving ahead as well. If also stands predicates and the true sets negating a conditional statement. So why these discrete logics are useful? Let me give you an example. So in maths, there are most of the hypotheses that are proven based on the fact that we are able to prove that their negative does not imply. So let's suppose if you have to prove A is equals to B, how it will how you're going to prove that? So the most common is you are going to say that let's say A is not equal to B. You are going to prove that, and you are like in the end it will go down like that is not possible. Some kind of equation form of that is not equal to B. So that's how most of the like hypotheses and theories are proved that A is equals to B. So same way machine learning works in that manner as well. You will be given certain aspects, certain statements while you are working on text generations, certain logics as well. So there you will pass that, okay, this condition is true, and now we have this condition. Does it matter? Does it mean, uh, are we required to do certain operations on that? So that's where some aspects of discrete maths or logic formation comes in handy. Otherwise, like in detail, in depth, they are not required also of that much. So yeah, we are good with discrete mathematics. Now moving towards the next topic, which is statistics, you can say. So most of you will be familiar of like, okay, they have given that here as well. So what is mean? Sum of observations upon number of observations. What is median? Like the middle value. What is mode? The value occurring the maximum number of times in a table. Standard deviation. Deviation is basically you understand like how much your data is diverse from the mean. Like you calculate the mean and then you calculate, okay, that much variety of diversity in my data. Variance, square of standard deviation, like it is also represent the diversity. Probability, you must know like the probability of an event to occur is between 0 and 1. 0 means no, 1 means yes, and like based on that. Distribution, normal distribution, quadratic distributions, or uniform distributions, like they used to describe how your data is distributed. Like you say, if probability of getting one is this percentage on a dice, probability of two is this percentage. so on, so on. So based on that, in the last you calculate like, okay, uh, that from the total, o- okay, if you are given that one occurs that much number of time from total two occurs that much number of time, so in the end you calculate like the probability of occurring of one is this, two this, three this. So that's a distribution. Hypothesis testing, that's from discrete mathematics. What I've told you in the last part, like how you calculate the hypothesis, therefore testing correlation, like okay, the relation between the two variables in the simplest of manner, and regression. And regression is just basically if you have two variables like forming a relation with the second variable from the independent variable, how you calculate the value, how you do all those stuff. So that's just covering statics. This is the basic. So most of our work will relies on regression. Regression is one of the most used machine learning techniques, and distribution is something you must be aware of. Like all of these are really important. Moving ahead, and when we come to descriptive, uh, okay, descriptive statistics. What are descriptive statistics? That just basically describes what is occurring in the text. Central tendencies, mean, median, mode, variable, univariate, like one variable, two variable, bivariate, two types of variables are there. Visualizations is basically how you are plotting from the data you have received. You have line chart, bar chart, pie chart, and so on. Outliners, like how you are calculating the scores, such as z-scores, box plot points. Z-score is the method. Let me just give you the exact definition. This is some used to calculate like uh, you can say the measurement of the overall score, like between 0 and 1, obviously stands, and it's some kind of probability, like one score means good for that and 0 doesn't. So, yeah, that's just basically like how much deviation from the standard mean it has. And descriptive versus inferential. Descriptives is the study which we study on like stats, and inferential statistics we like data sets used to make the decisions for us from like logical part. Explain like M5. Perfectly AI generated means of describing features of a data set. Examples you can all read through. Uh, yeah, that's just a read through topic. Nothing to be taken here. Definition types. I guess we've gone through that. Yeah, there's all of these are there. We variate by variate. Class types, scatter, data chart. Yeah, just to make sure like all of these topics, you don't worry, you'll be covering them in Python. I'll be taking through the whole of the like beginners to advanced course. So covering that you don't require any human resources. Now, what is data visualization? That we'll be covering via coding in Python, how you visualize. But here, let me just give you the brief. Not only brief, like, okay, what is data visualization? I've told you in many videos, like in data as well of AI and ML as well. So importance of data visualization is very important for the business insights as well, and for the machine learning insights as well. So while you're working with data, you should be aware of like how you want to show your data, how you want your client to see the data as well, and how you want your team to process the data. Let's say suppose if you clearly indicate them based on the data, like applying some queries as well. Um, like okay, uh, sample bar chart. Let me just give you the example of that. Okay, let's say this number of sales. So based on that, for business insights, okay, you say product ABC, which is in the trend in the current years, product C. So that will enable your company to know where to focus. Product B is something mediocre, so they know how to invest their time, money, and energy and resources as well based on these things as well. And while you are doing for machine learning, let's say, and okay, this will work fine. Mm, For example, yes, okay. So let's say here, if your central tendency, like these are some of the six variables, their occurrence and their like decision making while choosing your data set. So if you are aware that this, and this, these variables impact your decisions and are very close like to the outcome. So you give high priority to them, you give low priority to them. So that's how you make your model learn in a better and effective way, but clearly indicating, okay, don't focus on all of the all of the tables. It will be too complex for you. Focus on what's important and how you're going to know what's important from via data visualizations as well. So it is really helpful as for business insight as well, and it's for decision making as well. Yeah, idea generation, visual discovery, data visualization, tables are like Excel table. Pie charts are very helpful, like when you just want to coverage everything at 360 degree and want to know what, like which is the most. Line charts are one of the most used. Histograms, um, bar chart are one of them. Scatter plots, like just stores, like when you have very scarce data. Heat maps, like just to focus which is exactly the most populated data. Entry maps, like nested shapes. Yeah. um, Simple. So I think in data visualization as well. So what are we doing? Cross and charts and down. Inferential statistics. Okay, starting one is descriptive. Now come inferential. Inferential was is basically the data set on which we are actually making some decisions. So descriptive comes central tendency, variance, where you will calculate the data, describe the data. Okay, this is what my data does in a simple way. The descriptive analysis of the data. Now comes with inferential statistics. Is that like, okay, you have data. Now you want to collect, now you want to gather the information. What are the decisions I have to make with this kind of data? So you can use probability, you can use variable settings as well, random selection, sampling error. Uh, okay, like let's say you choose a sampling error. Let's say you choose a small sample to do the calculation. So what happens in that small sample is while your data might be very diverse. So if not properly cleaned, so the sample which you have chosen for testing might not properly indicate your data. The perfect characteristic for choosing a sample to test your data should be your sample should cover like the whole diversity of your what your data can give. So that is one characteristics, point estimate, interval estimate, estimate of a parameter values, confidence intervals uses the variability around the statistic to come up with the interval estimate for a parameter, which basically tells you like how strong your what do we say parameter or sample which you have chosen for testing is, how much it is like biased to the correct point. So precisely for a parameter you're interested in, the confidence interval tells like whether you can use that or not. Hypothesis testing is just the same what I've taught you before, using inferential statistics like this rule implies or yes, not, if this then this, that's the cause. Okay, if truth table hypothesis testing. So that truth table starts for if what true, true, if true, false, 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 true, true, false, false, true. Because if the first one is false, then it doesn't matter like what hypothesis the second is. Uh, because, okay, let me give an example. Like if you have two statements, so how are you going to generate the third? You check the order of the two are correct or not. So if both are true, yes. If first is true, second is false. So you know that something is breaking in between. So there your value is false and you generate accordingly. But if the first thing is false only, so the loop breaks here, there and then. So you don't have to check the whole both statement. So in the end, the overall result is true and your model or whatever you are generating like executes the answer in that manner in terms of machine learning. Comparison test, same t-test and over test. Like if you want to deep dive into that, you can learn, but these are just basically proving like if samples are worth trying or not. Regression, displacement, calls, all these are like part of that. So none of this is like okay, you should be reliable. Probability basics, I don't know what there is in the whole book. Let's see. But okay, the based on probability, what I've studied and learned, it's just basically like the chances of a certain event to execute. We have odds in favor and odds again. Odds in favor is just basically the formula of 1 minus p by p, or something like that, and odds against is the 1 minus of a if odd against is b. So that's how you test for them. Let us just verify the formula. Yeah, number of favorable outcomes, one number of unfavorable outcomes, and odd against is 1 minus that. 1 minus p upon p, like I just set the inverse. So, okay, um, what we're doing, we're waiting for the book to load. Till then, we just go through some, like, some of the things in probability, what we are covering here. Nice website, like this one. Yes, it is. So, heads or tail, probability, like, these are some of the basic questions. If you're just starting, you should do them. But yeah, you must be aware of probability and words, like how much they're going to repeat. Deco parts, all formulas, but there are nothing as such to be done in detail. In terms of this, okay, that's a very long. So, Venn diagram, that's in class book, I guess. Dependence of event, yeah, dependent event, independent event, that comes in really handy while doing probability, like if you're giving two events, like what is the probability of occurring of this? So, yeah. Uh, we don't have to do that, so then choose continuity of the, yeah, for the blue distribution and random variables will be covered that here in the next as well. So yeah, that book is something if you want to read it, go for it. Bayes theorem. Bayes theorem like basically states that if you have the probability of occurring of the second event, then what is the probability that that event is a part of the first? Now the two events are interlinked. So Bayes theorem is just okay, like yeah, if there is fire and smoke, like these are two. So when the smoke comes, if there's a fire, so how you calculate if there's fire and smoke? Like if there's a fire, probability of fire, probability of smoke when there is fire, like these two are intercorrelated, right? So fire when there is smoke. So you're giving that, okay, there might be smoke. If there is there fire, and that is something like, hey, there is fire. Like if there will be smoke, so probability of smoke, and then you get it is 9%. Like yeah, cloudy and rain. So you're giving that it is cloudy. It will rain or not. So probability of raining, probability of clouds when it is raining, and probability of having clouds. So you are giving these probabilities. It is very useful bias theorem. It comes in super handy while driving a lot of conclusions as well. And in decision tree, that one of the algorithm we use it very much to choose the main node. So probability of rain, probability of cloud when rain. So if you are given the probability of certain events and their correlation, you can find out like what you actually want based on that bias theorem. So it is just that a single. Let me write to you how it goes. Minus bias theorem, probability of A and B is equals to probability of A multiplied by probability of B when A, and that whole is divided by probability of B. This is that simple. And um, let's go back. Bayes theorem, I guess we are clear here. And random variables. Random variables is something which you have like the random output. Like if you choose a coin, the probability of um, if you toss a dice, what are the random variables? 1, 2, 3, 4, 5, 6. The probability of existing of those in the random phenomena within the finite set. These are called random variables for a certain like probability execution. And based on those random variables, you define like what are the probability we are getting that, what are the probability we are getting the other random variable, and so on. And the probability density function basically tells you like the probability of the continuous what we say random variable to occur for a particular curve. Like you draw a curve, like occurring of this is 25%, this 50%, this 20%, and so on. So based on those curves, you analyze like these are the variables that are occurring that much based on the probability, because sometimes the equation becomes too complex that you cannot analyze directly the equations. You have to go via the probability functions. So that's where probability distribution function comes in lot of handy. And yeah, probability functions, normal distribution curve, like probability of something 0.0025 and so on. Yeah, random variable is something which I've taught you, like the all the like possible outcomes of that. Variation is simple. Here variance will be very simple as you calculate in the statistics parts. Sigma xi minus u whole square, like xi is the individual value of the data set and will be your mean for that binomial random variable and so on. So the concept goes similar for all of them. And the types of distribution. Types of distribution is basically like based on probability distribution functions. What are the type of distributions you can have? You can see out here. Bar chart, weight, line, and so on. And just it goes like the type as well. All the important probability distribution functions which are required. I have noted them as well. That's just a simple calculation. Okay. What is probability density function? How do you calculate it? It's a function continuous variable, random variable fx is a function of x. X value is this, 0 this, find c. You can use property 2, uh, like go to the limit 0, otherwise, so we have mentioned infinity to plus infinity. Then we break it till 0 and so on. If greater than 0, 0 to infinity this, then we integrate and get that. Thus we must have c is equals to 1. Otherwise 0. So CDF is composite like random density function and so on, which is not required. Okay, like important probability distribution functions. This is calculation based on like x variable, mu, standard deviation, and how you now you calculate the z-score as well, which is discussed. Okay, sorry, I opened the wrong one. And yeah, all the important distribution functions are right here. Gaussian distribution function. We can open and check how it looks like. Normal distribution function is just simply the graph which is pointing, which has only one tip, and yeah, symmetric bell-shaped continuous polarization moves at a point cluster around a central mean with frequency tripping off towards the tails, like here, here, somewhere like that, where it's basically said like 68% somewhat of the data like falls between the plus and minus within the mean. And now what we have now, Bernoulli's distribution. All these distributions you must be aware of, like there are many. If let me just show you all the kinds of probability distribution, close this one. Yeah, all of these you can say are the probability distribution functions, and the list goes on and on. Researches will go on, you will get some new every time, but you just have to focus like what is the currently needed at the situation and on which we are working on. So Bernoulli's distribution, like see some images 0 and 1. So it works around 0 and 1, B for Bernoulli, B for binary. You can remember it in that way as well. And it gives the outcomes in the form of 0 as well for each type of random variable, which you can say, let's say, like compromise the probability of them as well. Multinomial distribution is something that generalizes the binomial distribution to model outcomes across multiple categories. Like here you are categorizing your data into different ones as well. Um, let's say, yeah, uh, in different categories, category A, category B, category C. It might some high, some types, it might low in sometimes. So that helps you clearly define the distributions. K possible outcomes into a fixed probability. Categorical, yeah, it just clearly an indication of the multinomial as well. It will clearly help to define all the types of category and gives out the specific probabilities within them. Binomial distribution. Binomial is something like it's related to your binomial calculation, like your permutation and combinations, NCR. Um, okay, binomial tree you must be aware of, like which goes 1, 1, 1, 1 to 1. So let me just show you binomial tree. Okay, let's see with this one. This is something related to machine learning, but okay, we can cover it. Here it is 1, here it is 1, 1, 1, 2, 1. Like the middle is the sum of these two. 1, 1, 2, 3, 3, 1. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Here you will get 1, 1 plus 3, 4, 1, 4, 6, 4, 1. The constants you are getting here are the values when you expand the component a plus b to that power. A plus b to the power 0 is 1, a plus b to the power a plus b 1 1, 1 to 1, a square plus 2ab plus b square, 1 3 3 1, a cube plus 3a square b plus 3ab square plus b cube, and so on. So that's something is the interesting part about binomial. You can calculate it that way. So p is variable a, 1 minus p is sometimes kind of variable b, and then you can calculate the distribution based on that, like how your data is distributed. It just gives a simple like hill type chart which you can use to identify your data distribution. Uniform distribution is something, as the name suggests, all data is uniformly distributed. Let's just go through the charts as well. Yeah, it's always a straight line. Exponential is the exponential curve. Poisson distribution, that's something is important. Like, okay, let me just highlight the important ones. If I copy it or not. Yeah, in Poisson distribution, what you see most of the times is something like this. So here it starts, it goes to a certain high and then it degrades very slowly. Um, let's just go through here and just send, yeah. That expresses the quadratic number of appearing in a fixed number of times they appear within a constant mean data and independently of the time since the last event. Like, yeah, it's basically time related on the y field. We are having like the variables lambda, their deviation, and it keeps on increasing. Log normal and chi-square are not uh, that much required, but you should be aware of. Chi-square is something which we log is something like much related to logarithmic. Um, when whose logarithm is normally chi-square distribution. Like if you've done exponential, you must be aware of that as well. Chi-square is something which we use in testing as well, like chi-square. Yeah, that's score you find out and then you calculate based on that. So that helps you find those values. It goes more like this. It's slightly different from Poisson distribution in that similar in that pattern as well. Um, so yeah, by that I guess yes. Next we have Python. Okay, so with that we have completed the maths part 2 here as well. Most of these topics you might sound like there is a rush, but no. These topics we only have to focus what is generally required while we are dealing with the models, while we are building them, while we are going through their algorithms. Because the videos, the concepts given here, the notes of each of those topics can cover one single section of the video if we go and try to cover them in detail in that much depth. But that is not the need of the hour. We generally require to like cover these topics and just basically like gather the insights on them. So we can do it in that way as well. And yeah, for discrete mathematics, whatever I've told you, like graphs, sets, and all those, keep that in mind because the logic part is something which we are going to use in the model as well for statistics. You should be strong enough with the maths like mean, median, central tendency, probability, something which we are covering, and like let's say regression as well. Regression is alone very useful in some machine, what we say, unsupervised machine learning algorithms. We highly use regression there. Probability, basics, Bayes theorem, random variable distribution as well. So all of these comes in handy while you calculate. Obviously, you calculate like the AI gives response in terms of probability, like 99%, 98%, and so on. So that's where probability comes in a lot of handy, which you have to cover there as well. So with that, we finish the math course. I'll be sharing the note on the GitHub link as well, which will be in the description. And yeah, for those parts, you can understand. If you don't understand anything, try contacting me. You can ask any doubts on the comments as well on LinkedIn as well. I've shared. And yeah, uh, keep keep learning, keep practicing all of these topics. You should be good enough with the hands-on practice as well. If you are not yet, and you should try to do them once, because by reading you should only remember the theoretical concept. But if you try doing numericals, if you solve queries, if you research certain aspects yourself, you will come to know some really important things about this, about those topics as well. For now, the theory section good enough to go with the machine learning part as well. So yeah, and if you like that video, please like, comment, and share. Um, you can share on the LinkedIn as well. Engineering with Dhruv, hashtag ENGG with Dhruv. So yeah, learn and practice, and we'll connect with next time with the fundamentals of Python. We're going through some coding assignments as well as we like go on with the more practical approach. So that's something that is like theoretical. Then yeah, with that comes in like your practical aspect, and we'll try to cover each of that topic with what we require in depth as well. So till then, keep practicing, keep learning, and good night. Bye bye.